So we are still discussing our overhead cost, and we are looking at classification or cost estimation, and we have been looking at high-low methods in classifying or estimating an overhead cost. So let's continue with our discussion on overhead accounting. So this example, we have looked at it in our previous part. Yeah, that's the solution we have made. So we cannot go through it again. Next illustration, we are still using the high-low method to determine, to separate overhead from. So this is our overhead cost. These are the level of activities. So if you look in this, what is the lowest level of activity? The lowest level of activity is this. So this is Apple. That is our lowest level of activity in Apple. Highest activity, highest is this. So once you identify this, the lowest level of activity is in Apple, and the lowest is in April, and the highest level of activity is in June. So meaning that you can be able to determine our variable cost. So our variable cost, as we have said in our previous formula, you are getting this highest activity, which is 23,930 minus 19,930 divided by 3,500 minus 1,000. You get B. Then substitute in our cost function to get the fixed cost, and then you separate your costs. So another method is accounting analysis, and when it comes to accounting analysis, it is the accountant that examines and classifies each ledger account as variable, as fixed, and the fixed cost. So in this case, it's about using personal experience of the accountant and the inspection, and in order to identify the cost. So we don't have any calculations on how to do it. You just use an experience, and then you identify these costs as fixed and variable costs. So you can go through this illustration. So we know direct material, materials, direct labor, material, repair and maintenance. So the direct material, these are variable. These are variable, variable. So it is very simple for you to determine your cost function. So this is the total variable, total fixed cost. So you can input the units. So you can put in here in your function and be able to determine the total cost. So these are 700 units. So you can determine the variable cost per unit. So if this is 700, these are 700. So what is our variable cost per unit? This is the information we have in our question. The variable cost is 280. The number of units are 70,000. The fixed cost is 20, and our cost function is this. So from here you can be able to determine the variable cost per unit. Variable cost per 1 unit, which is going to be 280 divided by 7,000, and I think you get 40. This will give you 40 as your variable cost per unit. So what is our question? Our question requires us to estimate the cost of producing 20,000. The cost for 21,000 units. So in this case, we are substituting in our cost function. Y will be equal to A, which is 20, plus B, which we got as 40, times X, which is our unit, which is 21,000, and then you get your Y. From that, using your calculator, it can be simple. So please try this illustration. We know cost of stationery to student per semester. Is it variable, fixed? So this is a variable. So you should use this information. And depreciation is fixed. Administration is fixed. Electricity and water per semester, it is fixed. Cleaning service cost per week. Other fixed overheads. So you can use this information to determine, establish a cost function. So another method is engineering. This one it uses on detailed study of operation to carefully separate material, labor, and equipment that are necessary to produce the products. So in this case, you are using engineering methods to separate these variables or these overhead costs. So another method is the visual fit, what we call scatter graph, some say scatter diagram. Visual fit, you allocate or you draw a diagram and allocate your points on graph. So you have a graph showing your cost and showing your output. So in this graph, you draw a line of best fit, and then from after doing the line of best fit, you determine the gradient of that line, and or what called the slope of the line. So the slope of the line will be the change in y over change in x. So once you get the slope now gives you a variable cost. So once you get the variable cost, then you can be able to determine the fixed cost, because this is going to give you the variable cost. Then from that one you can be able to determine a fixed cost. So you can look at this example. Assume the company's costs data show the total cost of this. This is the total cost respectively when the outputs are this. So estimate the total cost function using the visual fit, and what would be. So we draw our line. So we can take 2 points on this. So if you get 2 points on this. These are different points. You can get 2 points on your graph, and then you draw a line of best fit. So you just get the change in x, which can be change in x, which is can be this one, 1 million minus 4 million minus 1 million over 400 minus 200. Then you get the change in x, which is going to be your variable cost. So once you get the variable cost, then you can put into your cost function and then determine the fixed cost and other variables. So the last method that we talk about in cost estimation is what we call the regression analysis. So the regression analysis, sometimes they call it linear regression or least square. So you just have a simple regression, and once you get a simple regression from the regression, you can be able to, from this regression equation, you can be able to determine a fixed cost, and you can be able to determine a variable cost. So what you need to know, or what is the most challenging part the most challenging issue, is to identify what is my dependent variable and what is my independent variable. So if we have cost and output, what is the dependent, what is the independent. Because if you don't get that one correct, then you are going to make a mistake on this. So if you say you have cost and output, what depends on other? So the cost depends on output, meaning your dependent variable will be cost, then the independent variable will be the output. So you draw, you have your regression equation, which is y is equal to a plus bx, and then this one is your dependent variable, y is the dependent variable, and x is an independent variable. So if it is cost and output, it means this is your cost and this is your output. Now A, as we said in the previous, our A is the fixed cost and B is the variable cost per unit. So once you get this, then you can be able to determine A using the formulas below. So our B, if you are getting our variable cost per unit, will be any summation of xy minus summation xy times summation y over n summation of x squared minus summation of x, but in bracket squared. Then you can be able to get your B. Then your A will be summation y over n minus b summation of x over n. So let's look at this simple example. So this is your output. We said output will be the output is the independent and the cost is the dependent. So let's look at this illustration as it was in our notes. We have this will be our n. So we have n is 6 because there are 6 months. So this was our output, which we said it is our x. This is our cost, which we said it is y. Then we need x squared, and then we also need xy. So x squared, you just get the square of this. Xy, it's a matter of getting x times y, you get this, and then you get these totals. So applying our formula, where we said b is equal to summation of n summation of xy minus summation of x times summation of y divided by, sorry, the formula moved a bit, divided by n summation of x squared minus summation of x but with square. So if you put it here, so you get our n summation of xy, we get this, and then our summation x is this times summation y divided by n, which is 6 times summation of x squared minus x summation of x but summation of x squared. Then you get our b as 78. So after getting b, then you can get your a, which we said our a will be summation y over n minus b summation of x divided by n. So you substitute in our figures that we have already got in this table above here. If we substitute in our figure, then you have our summation y, which is this 35,100 divided by 6 minus b, which we have already got up here, which is 78, then times summation of x, which is 290, divided by 6. So this is the sum, this is this, and this one is this. So we get this minus this, we get our a as 2080. So remember our question, they want us to estimate a cost of producing 150 units. So our cost function is y is equal to a plus bx. So you are getting our a, which is our fixed cost, which we have got from here, which is 2080 plus our B, which is 78. We got up there, then times the units. So our cost for producing 150 units will be 13,780. You can also determine the correlation effect of this. The correlation effect, the coefficient of correlation, which is the degree between the relationship between the variables. You can use the Pearson-Lanka correlation or Pearson coefficient of correlation to determine the correlation effect between the variables. So to get the correlation coefficient, still you are using the data that you've looked at. N summation of xy minus summation of x, summation x and summation y divided by the square root of n summation x squared minus summation of x squared minus the square root of summation y squared minus summation of y squared. So it means in our table we need to add two columns. If you look in our table here, we need to add two columns to be able to get the coefficient. You need y squared, which you can get from here. You put equal sign 100 power 2. Yeah. That is your y squared. Scroll. Then you also need summation of y. We have it. We only need this only one column to get what we want. So you can continue with this and get the coefficient of correlation for this data. So if you remember our discussion when we are starting this chapter, we said that when we are accounting for overheads, mainly we have three major steps. The first step was to correct and classify the overheads. That is correcting the overheads in the cost centers. Then after correcting those overheads in cost centers, then you classify those overheads, classifying them into variable, fixed, semi-fixed, and variables. Then another stage once you have corrected and classified the overheads, then you need to apportion, because as we said, some overheads may be direct, but other overheads may be indirect. So because some of the overheads are indirect, we need to apportion those overheads. Remember, we are looking at which is allocating and apportionment. So if an overhead is direct, you can just assign it to a cost center that where it belongs. But if the overhead is indirect, then you need to apportion. Apportion, you are trying to divide the overhead to different cost centers. You may find that you have 5 cost centers, but those 5 cost centers are supervised by one person. So at the end of the period, you need to determine the cost of this supervisor to all of these, or you need to divide the cost of this supervisor to all of those cost centers. That's what we mean by apportionment. So because they are indirect, you can't just assign them direct. You have to just apportion them. But when we are apportioning, we use what we call an apportionment basis or an apportionment basis. So these are different bases that you can use to apportion your overheads. For example, if it is area, for all space, you can use the area to apportion rent, heat, light, This can be used to use the floor area. So we also have the book value, which can be used for depreciation of assets and even insurance. Sometimes we use book value. Then we have number of employees, which can be used to apportion overhead related to personnel, office, canteen, welfare of staff. You can use the number of employees. We can also use weight of materials or cost of materials to have material handling expenses or storekeeping packages and what. You can use cost of material, or you can use weight of materials. We have technical estimates if for power consumption, water usage, they can be used. Sales revenue can be used in advertising, selling, and distribution expenses. Even in administration, you can as well use the revenues. Direct wages, if the direct wages, please, we just allocate them. Machine hours, general overheads, number of radiators, heating. So you use these ones to apportion your overheads. So we have this example. This example, it shows the overheads that were incurred. We have rent, we have repairs, we have depreciation, we have light and heat, we have supervision, and then we have repair to buildings. So these are different overheads that were incurred within the factory. So the additional information we have, these overheads were incurred in four departments: Department A, Department B, Department C, Department D. So area of square meter is this. Then we have the number of employees, and then the value of plant. Please, what is important in this part in apportionment, you need to know the apportionment base that you are supposed to use. For example, if you're looking at area, you just know that you are going to use it on rent, you're going to use it on light, you're going to use it on heat. Those are area. But if you look at number of employees, it means those are related to personnel cost. If you go to value of plant, you need to use it in depreciation, or you need to use it on insurance. So it is very, 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 very important to know an apportionment base that you are supposed to use. So if you look at briefly, we can. So let's look at this simple example. We are having a rent of these overheads, which are shared in these four departments, as we looked at: Department A, Department B, Department C, and Department D. So when we are calculating, as I said in our previous slide, we said you need to know the base that we are going to use. For example, our first overhead is rent. So the base for rent is the floor area. So we are going to use this. So what you do first is to get the total area. So you are going to add the total area for this, which gives us 4,000. That will be our total area. And then once you get the total area, to get the cost of rent in the Department A, we are going to get the area Department A occupies divided by the total area, then multiply by the rent expense. Then you can get the rent for Department A. It's the same for Department B. You get the area occupied by Department B divided by the total area, then multiply by the rent expense. You get the rent for Department B. The Department C is the same, and Department D. So another one is repair to plant. The repair to plant, you are going to use the book value of plant because you have the book value of plant. So the total book value of plant, if we add the three the department is this. So the repair for Department A will be the asset in the Department A divided by the total asset, then times the repair expense. Then you get this. For Department B, you will do the same. You get the asset in Department B divided by the total asset. Then for department C would be the same. So you do the same for depreciation. I've given you the base depreciation base for it's going to be the book value. Light and heat, you are going to use the floor space. Supervision, you are going to use the floor area, and the repair, you get to use the floor area to calculate. So watch for the video number 3.